So we got to So we're going to be doing, the first one will be graph the function f of x equals x squared minus 2x minus 2. Okay, so on this one, and it gives us numbers that it wants us to plug in, right? It gives us half of the chart. It gives us an x side and then a y, or f of x side. Those two things are interchangeable. Y and f of x both mean the same thing. Okay, what numbers does it want me to plug in? Again, I forgot my handout, so I'm just going off of you. Is it -2, -1, 0, 1, 2, probably?
2, 3, yeah. -1, 0, 1, 2, 3.
Now, remember what we learned on Monday about how to do this. Because if we did this all by hand, we would be replacing the x's in this function with each one of these numbers to see what the y is that would go with it to create that point. Okay? We do not have the time to do all that all the time. Remember, what you can do is go to your y equals button in your calculator, right? Y equals is the very top, very left button. And if there's something in there, clear it out. And you're going to type in whatever the function is. So again, that f of x right there is the same thing as saying y. So y equals, so you're going to type in the x button. Remember, the x button is that xt other stuff. Then if it's just a squared and not a different exponent, you can hit this x squared button right here, kind of just a little diagonal above the 7. So that'll give you the squared, and it'll also bring your cursor back down so it's not still up in the exponent. So then what do I need? I need minus 2x, so minus 2x, and then minus 2. Now you are going to be graphing this in Math Lab, right? So before I do my table to fill out the rest of my table, I am going to graph this to see what kind, remember, because when you're graphing in Math Lab, what's always the first step is you have to pick out what shape you're about to draw, right? So that you're telling Math Lab what you're about to draw. So I know now that since it's going to make that U shape, the reason it makes that U shape is because the highest exponent is a 2. Anytime your highest exponent is a 2 of your function, it's going to have that U shape. Okay, so now that I know what I'm going to be graphing here in a minute, now I need to fill out the rest of this table. And remember how to do that. You hit your second button, which should be a color. And then hit that graph button again, which is top right. So look what you have there. Do you see how you have an XY table? So now to fill in the rest of your chart, you're just going to go find these x's in that table and then put the y that goes with it. So my first x is -2, and my cursor just happens to be on it. So what's the y that would go with that? It should be 6. What goes with the -1? Oh, I bet you were off the line. What goes with -1? 1 does. What goes with 0? -2. You can see anywhere there's a sticker. What goes with the 1? -3. The 2, -2. And the 3 is 1. Okay, so again, you're just filling out the rest of that table from the table in your calculator, right? And then you're going to go to Math Lab and graph that. Okay, it is a parabola, it is a U shape. It's going to let you graph. It's just, then you're just going to pick points out of here to plot. Okay? Okay, yeah, let me see. Maybe you have something different.
Y.
And the y equals.
I don't know.
Let me see what y equals. Okay, now hit the X button.
The X.
This right here, that X. Now hit the squared, X squared. There, that now minus 2x. No, oh, go back. Now that's the negative thing. Here, this is minus. So hit minus, then 2. X. This is x. You'll get used to it. And then minus again. No.
Minus 2.
Yep. Now, graph. So there's the shape it's going to make. Now, to get to see that blue word table, so since it's blue, that means you need to hit the second button first. So hit that, and then table. Now, that's where you're going to pick out and fill out the numbers of your chart.
Okay.
Okay? Now, I am going to freehand this to show you why it does make that U shape, because if you'll notice, again, on homework, you're doing this in Math Lab. You're plotting these points in Math Lab. But just so you can see what is occurring and why this ends up making a U instead of a line is because, look what happens here. This point is at -2, 6, which means my X is -2, so I would go to the left 2. My Y is +6, so left 2, up 6. There's one point. The next point is at -1, +1, which means I would go to the left 1 for my X, up 1 for my Y. So left 1, up 1. So right now, just with those 2 points, anytime you connect 2 points, it's going to make a line. Okay? But when I keep on going in this, you'll see what's going to happen. It's going to start curving. What about this? 0, -2. So that tells me not to go left or right at all. My Y is -2, so I'll go down 2. So no left or right, but down 2. Oh, it's not 1, 2. Next point is at 1, -3. So to the right 1, down 3. Now look what's happening. I'm repeating a Y that I've already had. That's the mirroring that's happening because it's a U shape. If I go to the right 2, down 2. Right 2, down 2. Now you can see if you start connecting those points, that curve that's happening right there. Then the last one, to the right 3 and up 1. To the right 3, up 1. So I'll notice now, when you connect those points, it makes that U shape. Bless you. And again, that comes from it being an X squared graph. Okay? Next one.
Now to clear that out, I hit what?
So you're back in Y equals, just hit the clear button. It's right below the arrows. Are you on it?
The Y, the X and the Y graph.
Oh, go back to Y equals.
Oh.
Now
Okay.
clear it. Now hit clear.
Okay.
Because now we're about to type in this next one, which is I forgot. Negative x squared minus 7. Thank you. Okay, so again, I'm filling out my chart. Is it the same number? Negative 2, negative 1, 0, 1, 2?
Yes, negative 2, negative 1, 0, 1, 2.
Now, once again, I don't want to mess with plugging all this in, so I'm going to go to my y equals and clear it out. Now, be careful when you're typing this one in. This is a negative x squared minus 7. The negative button and the minus button are two different things, right? The negative button is the button below the 3. So that's what I'm going to hit for the negative in the front. So negative, then again, there's my X button, the one that has all the letters on it. And it's squared again, so I'm just going to hit that X squared button, right? It just gives me the exponent. It doesn't give me the X. It just gives me the exponent. So negative X squared. Now you're hitting minus 7. So before I do anything, what is this going to do to my graph? It's going to make it a U, right? Anytime your highest exponent is a 2, your graph is going to be a U. But now hit graph and look at that one. It's a U, but it's upside down. Still a U though. It's just upside down U. Why do you think that one's upside down, but the other one wasn't? What do you think made this one flip upside down? That's exactly right. That negative in front of that x squared is what flipped it upside down. Okay, we're going to get way more into that later on. Okay, right now we're just going to focus on filling this out. So let's see. I'm going to go to, where do I get to my table? Second graph. Good. There's all your numbers that you need to fill out the rest of your graph. So then you're just using these numbers and picking the y's that go with them. So what goes with negative 2? That's right. Negative 11. Negative 8 goes with the negative 1. 0. Negative 7. 1. Negative 8. So see when the y's start repeating? That's the mirroring. I guess this one will be upside down. That's the mirroring that's happening in the U. Will? Oh, sure. Yeah, anytime. 2, negative 11. So let's see, negative 2, negative 11. Where's that point going to go? The x is negative 2, so I'll go left, down. Left 2, down 11. Left 1, down 8. Left 1, down 1, 2. 0. Negative 7. So my 0 for the x tells me not to go left or right at all. I'm just going to go straight down 7. 1, 2, 3, 4, 5, 6, 7. 1, negative 8. So that would be to the right 1 and down 8 this time. So remember that U, upside down U that you saw in your calculator? That's what's happening right here. 2, negative 11. This time to the right 2. And down 11. All right, then one more graph. It looks like x cubed plus 9 for number 14. So now my x is cubed, which means it's not going to make a u anymore, right? That's what is making the different shapes, is what is occurring to that x. So this one is x to the third plus 9. So again, oh, I keep forgetting to look. Same numbers, I'm assuming -2, -1,
0, 1, 2.
0, 1, 2. So again, back to y equals, clear it out. Hit my x button. Now, x to the third power, that third power doesn't have its own button like the squared does. Okay, anytime you're typing in an exponent that's not squared, you hit this little up arrow thing. It's right below the clear button. That puts look at your cursor. Once you hit that, didn't your cursor go up into the exponent area? So type in your exponent to be 3. Here's the other thing that happens when it's not a squared. Remember when I hit that squared button? It put the squared up there and then put me back down in the normal area. Well, look where my cursor still is. My cursor is still up in the exponent, even after I type in that 3. So you don't want to keep, I want this plus 9 next, but I don't want it in the exponent. So to get out of the exponent, just hit your right arrow button.
Okay, say it again. First, hit the arrow going up.
So you hit the arrow
under the clear button.
Hang on. I'm going to start all over. X, right? Your X,
okay.
Your normal X button. Now, to type in that 3 exponent, I hit not in this area. This little, what's that called? I don't know what that's called.
The arrow up under clear.
Under clear, yeah. So, okay. Now, right. What do you need to put in there? 3. Now,
3.
You want your cursor to still be in the exponent. Is your cursor still in the exponent?
Yes, yes.
Okay, you don't want it in the exponent. So now hit this arrow to the right button.
Oh.
That'll get you out of the
exponent. And it brought it down.
That brought it down.
Yes, it did.
Exactly what you want. Because this plus 9 is not in my exponent, right? It's down in the regular area. So now,
yes, ma'am.
Then plus 9. Now, remember, in Math Lab, what's the first thing you're going to have to do every time when you're graphing? Tell it the shape. So I want to graph this. So just hit your regular graph button to see what kind of shape you're going to make. Okay? It's kind of even hard to see because it goes right here. And then after it does this little juke right here at the top of this graph, it goes back, it goes up that way. That's what an X cubed graph looks like. Anytime you're drawing an X cubed graph, it's going to resemble something like that. Okay? It's just that what happens, this top Y right here is a 10. Your graph just doesn't go up there because our window is not set for it to go up higher than that. Okay? We'll work with messing with windows later. So now what do I need to know? I just need to know this. What are you going to get to the table? Second graph. There's your table. So -2 goes with a 1. -1 goes with an 8. 0 goes with a 9. 1 goes with 10. And 2 goes with 17. So let's see, -2, 1 would be left 2 up 1. Left 2, up 1. -1, 8. Left 1, up 8. The left 1, up 1, 2, 3, 4, 5, 6, 7, 8. Zero, 9. Left or right, 0, up 9. So there's my juke that's happening in that squiggle shape. 1, 10. So to the right 1, up 10. And then this last one is 2, 17. So do you see why when we're in the graph, we don't see the end up, right? We don't see the top of it because it's 17, which is to the right 2, and then up 17 is going to be somewhere up here.
Then how do you hit the 2? Then he goes right
I
over
went
2.
right 2, and then
Up
up.
to 17.
I'm just kind of guessing where the
Okay.
17 is.
Okay.
It's just way up
I
there.
got it.
Now remember, how do you check, how do you know for sure when you're graphing in Math Lab, where can you look? Remember in that yellow box that's on the top of your graphs over in
Mhm.
area? You'd be looking for it to say 217 to drop that point, right?
Right.
Yeah.
That yellow.
And this is a cubic function, and I think it maybe makes you plot, it's either 3 or 4 points to draw it in the graph. But you got plenty, right, to choose from. Now, this next section wants us, remember we talked about what makes a function or not. A function is a correspondence or a relationship to where each element in the domain only goes to one element in the range, okay?
Right.
What if you're just looking at the drawing of a graph and it doesn't tell you domain and range? There's a test that we can go by. It's called the vertical line test. Okay, here's what the vertical line test tells you. Okay, so here's what the vertical line test tells you. The vertical line, that's this one, right? The one that goes straight up and down. Horizontal, vertical. So what the vertical line test tells you is if you draw a vertical line anywhere on the graph, and that vertical line can only touch the drawing of the graph one time, not more than once, just once, that's going to make it be yes.
A function.
A function, thank you. Okay, so that looks like what the rest of these problems are. I'm just going to kind of free draw these, like number 15. We good? right? 15 looks something like that, right? Pretty close. So let's think about this. This blue shape. Anywhere I draw a vertical line. See, if I draw a vertical line right here, how many times did that touch that blue shape? Just once. How many times did that one touch it? Just once. How many times did that one touch it? Just once. Is there anywhere on here where I could draw a vertical line and have it touch that blue shape more than once? No. No, it doesn't matter where I put a vertical line. It can only touch the blue shape one time. That makes it, yes, a function, because I can't ever touch it more than once with a vertical line. So that's what makes it a function. Look at number 16. Okay, something like that, right? Not perfect by any means, but I don't really need it to be perfect because look at this. Now my shape is red, but if I draw a vertical line right there, how many times did I touch that oval shape? Once there and once there. I touched it 2 separate times. That makes it not a function. Okay?
I don't see where you touched it but one
Remember, the
time.
definition of a function is if one of the numbers in your domain, which are your x values, goes to 2 separate numbers in the range, which are your y values. Well, look, so this one, they have the same x. They've gone the same to the right, but they've gone 2 different y's, right? So that's why it's not a function, okay? It's much easier to tell on a picture whether something's a function or not, right? You just have to be able to draw a vertical line.
Okay.
All right, number 17, okay? For sake of time, I'm just gonna draw the shape of it. The shape of it looks like that, right? That's the shape of the graph. How many times do you touch it? Twice.
2 times.
2 times, which means what? Not a function, right?
Not a function.
Right. And the last one. Something like that.
What?
Right. That vertical line is only touching it once. That vertical line is only touching it once. This vertical line is only touching it once. I can't draw a vertical line anywhere on that zigzag function and touch it more than once. So yes,
Okay.
is a function.
Okay.
So vertical line touches once, yes, a function. Vertical line touches more than once, not a function.
Not a function.
Okay, now we are going to go into 2.3 because we do need to get through 2.4 this week. We're still going to be a little bit behind, which is fine. We got plenty of time to catch up. And again, I'm having to pull up the things on my computer because I forgot to bring my handouts. I had them out and everything and stuff like that. Okay, so I'm going to hand draw what is written on this handout. again, if you have printed it out, then you would see this on your sheet of paper, right? Yeah. Okay, so the first,
Right.
it's going to ask me several different things about this graph. Okay, you'll notice it's got A, B, C, and D. The A, I'm just going to write this out so I can go back to see, make sure I can see everything, because all I can see right now on my computer is this worksheet. So f of -2, then it's going to ask for the domain. Then it's going to say find any x values for which f of x equals 4. And then it's going to ask you to find the range. So 4 things. All right, f of -2. Here's what I'm finding first. The number that is inside here is your x. So what it wants you to do is find f of -2, which means what is the y that goes with -2? What does x meaning being -2 mean is happening? Left 2, right? So let's go left 2. Now, where is the point that goes with this? Where is that one? There's one point that has gone to the left 2. It's this one right here. Okay? Now remember, if you have the handout, yours is exact. Mine's free drawn, but it's pretty close. So let's see, to the left 2, what is the y? So this is the point that has an x of -2.
Miss Hanson,
Go ahead.
is this 2.3 finding the domain and range
This is,
worksheet?
yeah, 2.3, the very first one. I should have made that more clear.
Okay, I got you. Thank you.
Mm-hmm. So this is the one point that has gone to the left 2. What is the y value of this point? You trace it over
4.
to the axis. What is it lined up with? 4.
4.
That's exactly right. So f of -2 is 4. So that answer would just simply be 4. And I see I'm in that glare.
4.
The next part of this problem is going to be the domain of this graph. The domain is your x values. So you're just going to go, since this is just several separate points, you're just going to go through and name all the x values of those points. Where do each one of those points line up with the x-axis? Okay, so I'm just going to start with the one that's farthest to the left. So where is this one lined up with your x-axis? This one. No, x.
4.
What kind of 4?
Look like -3.
Is it?
-4.
Look like it.
Yeah, I know. So when you're doing this on Math Lab, you do have like a little magnifying glass by your graph. If you hit it several times, it will blow up that graph. So since the squares are so small, it'll blow it up for you so you can see it better, which you're probably going to want to do on problems like this. Okay, so this one lined up with the x is -4. So the first value of the domain is -4. All right, what about this one? What is it lined up with? X-axis. -3.
-3.
Good. Next point, what is this one lined up with?
-2.
This one's lined up with negative.
-1.
What is this one lined up with? It's lined up
0.
with 0, right? And the last two, this one's lined up with 1, and that one's lined up with 2. So that's the domain. Since it's just a bunch of separate points, you're just going to each point and naming its x coordinate, which means how far left or right is it. So that's the domain. The next thing it's going to ask you is, what are the x values when f of x equals 4? Remember what f of x is the same thing as y. So it wants me to go find where y is 4, which would mean up 4. Whoops. Now look at this. So here's up 4. There's actually 2. So anything, if you're up 4, that means you are anywhere in this line, right? That means if you are on that real faint line that I just drew, that means you have gone up 4. Anybody that is up 4 would be right there. There's 2 points that are up 4, aren't there? These 2 points are both up 4. So what are the x values of those 2 points? It doesn't matter which goes first. What's this one's x?
-2.
And what's this one's x?
0.
Oh, isn't it? So -2 and 0 are the 2 points that are where y is 4, meaning up 4. Then the last.
Oh, it doesn't matter if
Go ahead.
like on the x-axis is -4 or +4.
On the,
Oh, okay. I'm saying going like how you go over, how when you go up the y, it's on the 4, but I'm saying it doesn't matter if it's on the like the negative side or the positive side.
right.
Okay.
Yeah. If you are anywhere here, doesn't matter if you're way over here or way over here, do you notice that these 2 points have something in common? They have both gone up 4, which means their y would be 4. Their x's are something completely different, positive and negative. But if you are right there, like these 2 points were, that means your y is 4 because you had traveled up 4 to get there. Now, the very last thing of this is to find the range, which means the y values of each of these points, which means how far, in this case, up, because they're all up, how far up is this one? What is this one's y value? What's it lined up with on the y-axis? It's gone up 3. So the first number in the range is 3. Trying to be able to get all of it. Here, I'll just put it right here. These both have the same y value, right? They're both what? Up 4, which means
4 and 0.
a 4. So they're good. You just need to write it once. You don't need to write 4 and 4. 4 is just part of your range. These two have the same y value. What's their y value? 5. And then what are these two's y value? 6.
6.
Right. So the y values that are in this graph are 3, 4, 5, and 6. Well, yeah. Because this point right here, sorry, I made it blue. That point right there, what is this one's y value? If I was going to name this point with its coordinates, which means, how did I get here? What did I do? I went left 1, up 3.
Mm-hmm.
Means what would these two things be? Its x coordinate would be -1. Its y coordinate would be positive
3.
3. That's how I got there. I had to go left 1, up 3. So since I went up 3, its y coordinate is 3. Any of the y's count for the range. Do you see that why this point right here's coordinates are this?
Yeah.
You do?
Yeah, but I don't understand how breathe in the range.
Because range is the y's. What is it? If I name this point, what are its coordinates? How did I get to this point? If I started here, what 2 things would I have to do to get to this first red point? What's the first thing I would do?
Go to the left 1.
So left
and up
1,
3.
up 3 is how I would get it, which means my x coordinate would be -1. That's what made me go left 1. Up 3, which means my y coordinate is +3. If you are a y coordinate, you are a range.
Okay.
All y coordinates are range numbers.
Okay, I got it now.
Okay, good. Okay, let's look at number 2. Let me try to free draw this one. Okay, so remember, I'm free drawing this, which makes it not perfect. This point right there, because that looks like where it starts going like that. Let's see, where am I going to find it? I'm just going about what I'm going to have to find here in a minute. Okay, so the things I'm going to find are f of 2, domain, x values when y is 3, right? I'm just going to call this y instead of f of x. I'm not even going to mess with the f of x. I'm just going to call it y. And the range. Okay. What number is this inside here? What does that number represent? Your x. If it's in parentheses, that is an x value. So what it wants to know is what is f of 2, which means what is the y when the x is 2? So what does x being 2 mean? You've gone to the right 2. Now, what lines up with this x being 2? Which means from there, go up or down to touch your graph. Which means I would need to go what? Up, right? If I come over to the right 2, and then I'm going to go up or down to touch this graph, it would be right there. Again, if you're looking at a more exact printout, I tried to make this as exact as I could. So if I went to the right 2 and then I went up and touched it, what is the y value that goes with where that lines up on that shape? You just said it. 3.
3.
Good. So f of 2 is 3. Again, go over here on your x-axis to 2. Then go touch the blue graph. So if I'm going to touch the blue graph and line up with 2, that means I'm going to touch it right here. Then say, okay, I'm on the graph now. Where am I lined up to the y? Which would be that 3. Now, this is called, now the second part of this is asking me, what is the domain? So there's a couple different ways. Domain are your x values, right? So when you're looking at a graph, this one's not separate points like the last one. I'm not just going and trying to find the x values above a bunch of random points. This is a continuous graph. So when you're talking about the domain, you want to talk about how far, the domain is your x axis or your x values. So you want to think about how far left to right, right? That's what the x tells me, left and right, does this blue graph go? What do these arrows mean? Doesn't stop right there. That means since there's arrows on the end of that, it keeps going. So what does this arrow here mean this is doing? It's going to go forever up and left. This one's going forever up and right. Am I going to the left and the right forever? Yeah. So your domain is going to be all the numbers. It's eventually going to cover the entire x-axis because this means I'm going forever left. This means I'm going forever right. Okay. What do they call it on here? Okay. So x, look down at that E. It says the domain is all real numbers. It goes forever to the left and forever to the right, which means eventually it's going to cover the whole entire x-axis, all the x values. So all real numbers. What are the x value or values when y is 3? Oh, I didn't think this one all the way through. Where is y 3? Here's where y is 3. So anywhere along this, on that blue graph, you've gone up 3, right? How many points am I talking about that I'm going to have? There's going to be 2 of them, right? I went up 3 here, and then I didn't think this all the way through. I'm not sure this one's going to be exact. Let me go back and look at it and see where it actually is. 3, it looks like it's lined up with 8, actually. Make it work for us. There you go. So in those 2 spots, my y value would be 3, right? Because in those 2 spots, I have gone up 3. So let's see, what is this one's x? What is it lined up with on the x? 2.
2.
Good. What is this one's x? What is it lined up with on the x-axis? It looks like it's lined up right here. So 1, 2, 3, 4, 5, 6, 7, 8. So this one's x value would be 8. So when y is 3, I have 2 different points that have the y coordinate of 3, and their x coordinates that go with them are 2 and 8. Now, the range. This is not all real numbers. Why was the domain all real numbers? Because it went forever left and forever right. Your range, talking about how far up and down it goes. Look at your shape. What do these arrows mean? It's going forever up that way, forever up that way, but it doesn't go forever down. Forever down means that you would see some graph down here, first of all. So what is the lowest y value? Where is the lowest part of this graph? It's right here, isn't it? That blue shape doesn't ever go below that exact point, right? Everything's above it. It goes up from both directions, starting right here. So this is what your lowest point of the graph is. So range is what letter, X or Y? Y. So I need
Range is Y.
Y coordinate of this lowest point. What is this one's Y? What is it lined up with on the Y?
0.
It's lined
A
up,
5.
right? Its X is 5, but its Y is lined up with 0. So what is that telling me about the range? Doesn't it go up both sides from that 0 though?
But it's not gonna fall below the 0.
Anything above 0 or equal to it, because you probably have both options, don't you? Yeah. So you want to show X is, oh, I'm on the wrong thing.
Y.
Y, thank you, I'm on the wrong part of the problem. Y is what? All the numbers greater than or equal to 0. Y
0.
greater than or equal to 0, right? Your Y values are not ever going to be below 0. If you had, which means they're not ever going to be negative, right? All the numbers below 0 are negative. If you had any Y values that were negative, they would be down here. They would have gone down. There's not anything down there.
Right.
Okay. All right.
Got it.
We are going to stop there. Okay, so I am going to take roll, and that's in the clipboard that I didn't bring. So I got Anna, Ellis, Hines, Hauser. Who's admin? I keep forgetting.
Crystal. Keys.
Oh, Crystal. He's Carter Wilson, Jamie Bro, Peak, Payless, Sharonda. Okay, so that's all I have from Zoom. So I'm going to stop. I probably should have stopped before that. Okay, it looks like the support part of this section, the first part is going to be just reviewing solving equations, which we're going to have a little bit to do in the second part of 2.3. So right here, I just wrote the first 4 problems on the board, so I don't have to keep going back and forth and looking it up. So when you are solving any kind of equation, your goal is to get whatever the variable is. It looks like it's X and all these, well, except that one's Y. You want to get it by itself, right? That's the whole point, is you want to know what X equals. So the way that you solve the equation is whatever is with the X, you want to remove it in order for the X to be alone. And the way that you remove numbers is you just do the opposite of what it's doing already, which means if I'm going to I want this X here to be alone, which means I need to get rid of adding 3. What's the opposite of adding 3? Subtracting 3.
Subtracting 3.
Good. Now, what is the number 1 rule of any equation? If I do it to one side, what else has to happen?
Do it to the other side.
That's exactly right. Whatever you do to one side, you have to do it to the other side. So I'm going to subtract 3 over here also. The plus 3 minus 3 goes away. That was the whole point of doing it. So it would go away, and I would be left with just this X.
Was 38.
And then do the math on the other
38.
side, whatever you can. Right. So you do have 41 minus 3, which is 38, which is your answer. Just 38.
Gotcha.
All right, number 2 looks like this. Okay. And another good thing to remember is wherever your equal sign is, just bring it down. You want to keep it. It's like it has its own column and it doesn't move. Your X doesn't have to end up on any specific side of that. It just wants to be alone. Your X, it's kind of like it doesn't like anybody. It wants to be all by itself. So if this X wants to be, here's my X. So for it to be alone, this time who needs to disappear? That minus 10 needs to
10.
disappear for the X to be alone. How does what's the opposite of minus 10?
Plus 10.
Right, that's what's gonna knock it out, right? And if you add a 10 to it, that's what's gonna cancel it. If I add 10 to this side, I have to add 10 to this side. Doesn't matter which side you look at first now. Don't mess up here. If you don't like adding and subtracting with positives and negatives, punch that in, right? Negative 26 plus 10 gives you what? Negative 16?
16.
Good. Now, this minus 10 plus 10 goes away. So what's the only thing left over here on the right? If you're on
X.
X, that means you're done. The other side of the equal sign is your answer. So what does X equal? Negative 16.
Is it usually the largest number have the
Whatever sign it
negative
has.
or positive, that's what the sign
Yep.
will be.
Yep.
Okay.
So let's see, negative 5x plus x. I'm gonna rewrite it up here so it's not in the glare. Okay, I just rewrote it up there so it's not in the glare. So x wants to be alone, right? Who needs to go away? Negative 5/8. Okay, this used to be a big deal because it's a fraction, but I have this calculator now, which means I can just go ahead and work this using the steps I've been doing. I need minus or negative 5/8 to go away, which means I need to do plus 5.
Plus 5/8.
Good. If I do it here, I do it over here. So the good news is this side's easy. The negative 5/8 plus 5/8 is going to disappear. All I'm going to be left with is the x, which is good, right? X is alone. So as long as I can figure out what this mess is, I'm done. Now remember, your calculator will add and subtract fractions even if they don't have the same denominator. That right there is worth the price of the calculator, right? So let's see, what do I need to tell my calculator to do for me? I need it to do negative 7/24 plus 5/8. Tell it that. Tell it. So what do I need to tell it first? Negative 7.
How do I set the fraction up?
That right there, you just punch it in exactly. So hit negative 7. Negative is below 3, right?
Okay.
Negative 7. Oops, my calculator's not on. Negative 7. The way you make this fraction bar is your division button. Your division button will give you a bar that looks like this.
Okay.
So hit the divided by symbol, because that's what a fraction bar means. The top divided by the bottom. So negative 7 divided by, what do I need to put in the denominator?
24.
Okay, so there's negative 7/24. Now what do I need to tell it? Plus.
Plus 5/8.
Plus. How do I make 5/8? 5 divided by
Divided
8
by
will make your
8.
5/8. So 5 divided by 8. Now, here's the thing. Look what, hit your enter button. Ooh, MATLAB ain't gonna like that. Anytime you get a weird decimal like that, or it's not a whole number like that, you're gonna do 2 things, or you're gonna hit 3 buttons. You're gonna hit math button, enter, enter.
Enter twice.
Math. So hit your math button.
1/3.
So when you hit your math button, the very first thing in the math button function is that number 1. It says, it's got that little arrow and then it says fraction or frac. That means, do you want me to turn that 0.33333333 into a fraction? So you say yes. So that means enter. So again, it wants you to reassure yourself. Turn your last answer into a fraction, enter. So again, decimals to fractions, just hit math, enter, enter. That'll turn your decimal into a fraction, and not only turn it into a fraction, it will reduce it and put it in simplest form for you also. Okay? Math, enter, enter is your best friend on this calculator. All right, this last one, or not the last one, number 4, still solving. This time I'm solving for y. It doesn't matter. Whatever the letter is, it just wants to be alone. But here's the difference, and I can see why this problem is in the assignment. That 14 is not being subtracted from that. It's hooked on to the y, isn't it? Look at the difference.
Yes.
This is not hooked on to y. That means I'm going to get rid of it by just doing the opposite of whatever its sign is to cancel it out. This is hooked on to y. What does this say? If I said this statement out loud, this would say negative 14 times, right? If you are hooked on to something, that means you are being multiplied to it. This right here, 2x means 2 times x. This means negative 14 times y. So I'm going to use, so the opposite of it, which is how you remove things, right, is you do the opposite. That's why you add to get rid of get rid of minus. But this time I want to get rid of multiplication.
So you divide.
You're going to divide, and you're not going to change the sign or anything. When you are dividing, you divide by exactly what this is. So I am dividing by negative 14, because look what you have now. What's negative 14 divided by negative 14? Not 0.
1.
1.
Right, which means you're left with 1y, which is just y. So that's why you put it over exactly itself. Again, if I do that side, I have to do this side. Same thing. So I'm dividing both sides by negative 14. My negative 14s cancel here. That's why I'm just left with y. And then just punch that in your calculator. 84 divided by negative 14 gives you negative 6. All right, moving right along to number 5. I'm going to write several more on the board again so I don't have to keep coming back. Ooh, I hate it when I forget my printout. So negative 4, 10. Six x minus 1. Okay, I'm just putting several on the board so I don't have to keep coming back to this. All right, remember, x wants to be alone. This wants to be alone. What does this mean? What does that fraction bar mean? That means x divided by 4, right?
Mm-hmm.
How do you get rid of divided by 4? What's the opposite of dividing by 4?
Multiplying.
Multiplying.
Multiply.
Also, I've got to get rid of that negative. How am I going to make that side positive? I don't want to know what negative x is. I want to know what positive x is, or just x. So not only am I going to have to multiply by 4, I'm going to need to make it negative, because what's going to happen is that negative 4, the opposite of that 4 is going to to cancel out that 4, right? Because multiplication is opposite of division. This negative times is going to turn that positive, right? That's how you turn a negative positive, is you multiply by another negative. Right? When you're multiplying two negatives together, what does that end up being? Positive. So that's why you also need to multiply it by a negative. And the 4 is because you need to get rid of divided by 4 with the multiplying. So what am I doing to this side? I'm multiplying it by -4.
-4.
Which means I also need to do what? Right.
-4 over here.
Right. So let's see. The multiply by 4 canceled out the divided by 4, and the negative times the negative turned that to positive. So what's the only thing that's left over here, like I wanted? X.
X.
What's left on the right side? Just do the math if you want to in your calculator. 10 times -4, which gives me -40.
Now, let me ask you on that
Go
one,
ahead.
because the four is smaller than.
Okay.
Because it's in the parentheses.
Well, it's because it's when the rules change. Man, these negatives and positives rules are what drag the whole world down. Okay, this right here, if you are multiplying, which is what I'm doing, multiplying by -4. If you are multiplying and you have two different signs, it doesn't matter who's bigger, who's smaller, who's first, who's last. If you have a positive number and a negative number, your answer will be negative in multiplication and division. Multiplication and division do follow the same rules. You can kind of think of it like this. If you are multiplying and dividing different signs, your answer will be negative. Same signs, your answer will be positive. Those are the rules for multiplying and dividing. Same signs, positive, different signs, negative. All right, so that was 5. Benitra, is this one 6?
Yes.
That's a T.
T. Yeah, it doesn't look like it, does it? I try to make my T's not look like pluses. I would prefer them not ever use T,
I know.
right? I mean, there's 25 other letters you got to choose from. Why are you going to use a T? I don't know if that made it any better. Okay. Okay, so what is happening? What needs to go away for T to be alone?
3/5.
Is it hooked onto the T?
Yeah, so y'all divide it out, right?
Hooked on numbers. If you are hooked on, that means you are multiplied times that T, which means if I'm going to get rid of you, how do you get rid of multiplication?
Divide.
Dividing. So I just need to divide by whatever that is, which is 3/5. So 3/5, anytime you have the same thing on the top and the bottom of your fraction bar, it's equal to 1, right? Same thing,
Right.
top and bottom just means 1. So all that's left over here is T, which is good. I want the T to be alone. Now I just need to figure out what that mess is. I can punch that in my calculator. Let's go ahead, and this, you can't ever go wrong with putting parentheses around fractions. And you may need to on this one. I can't remember. Since it's a fraction divided by a fraction, when we type this in, let's type it in like this. That way it kind of tells your calculator who's the top of the division and who's the bottom of the division, because there's going to be fraction bars all over the place. Okay? There are other ways to do fractions in the calculator, but I feel like this is the easiest. So when I'm typing this in,
We divided it, right?
I'm going to do dividing. I'm going to do open parentheses, -1 divided by 10, close parentheses. So your open parentheses is right above your 8. Negative, remember that one's below the 3. So -1 divided by 10. And then I'm going to close it. So see how that's
Mhm.
negative 1/10 in parentheses? Because now I'm going to do
Yes,
divided by, and this time I really mean divided by. I'm not creating, right? I'm doing this divided by 3/5. So that's why when you put the two fractions in parentheses, it kind of separates them from each other on what you're dividing. So go ahead and hit the divided by again. And then put your bottom fraction in the parentheses. So open, 3 divided by 5, close. So you should have negative 1/10 divided by 3/5. It's probably going to give me a crazy fraction. I mean, not a crazy fraction, a crazy decimal.
Oh, okay. I'm gonna say
Yeah. But I want it to be a fraction, which means what do I need to do? Math, enter.
wait a minute.
Enter.
I'm at 3 divided by 5. I missed it.
You with me?
3 divided by 5. After 3 divided by 5, close the parentheses.
Then hit enter. Did you get negative 0.1666666, something like that?
Yeah,
Now hit math, enter to turn that into your fraction.
math. And maybe it's negative 1/6.
That's it.
Okay. This is a bad calculator.
It is.
Yeah, I'm gonna have to buy another one. My
Now
daughter gave
remember,
it to me.
there is an app called, hang on, I have it on my phone. And sometimes you can find the calculators for sale on Facebook Marketplace or in pawn shops for cheaper because they're over $100 unless you can catch a sale.
I know.
Yeah, no, marketplace could be like $50 or $60.
Yeah, so you're getting at least half price. It doesn't need to be brand new.
Okay.
Right here. Uh-oh. Why do I keep doing that? That bottom app, Calculator X.
Yes.
When I open it, look, it's a TI. It's a TI-84 calculator.
Okay.
So if you wanted to hold off, you could, Calculator X is the name of the app.
Okay. Calculator it.
Mm-hmm. All right. So here's number 7. 6x minus 1 equals 35. So now we have more going on, right? X still wants to be alone. This guy wants to be alone still, always. 2 things need to go away. What you can always be 100% sure of is the hooked on number, whatever is hooked on to your X, goes away last all the time. It's the very last thing. It's like it just wants to hang on to the X until the very end.
Okay.
Which means if that is going away last, who needs to go away first for this X to be alone?
1, negative 1.
It's 1,
Or
right? The
One
hooked on
minus-
number goes away last.
Okay.
So I want to
So
get
you add the 1 to both
minus
sides.
1. How do you get rid of minus 1?
Add 1 to both sides.
Okay. Add 1 here, add 1 here. So what's left on the left side?
6x.
6x.
Well, that's 6x. I still got that 6 hanging on. What's on your right?
36.
36.
6. What's the last? How do you get rid of the hooked on number? How do you get rid of hooked on numbers?
Divide it out.
Right. So x equals 36 divided by 6, which is 6. All right, number 8, 7x plus 13 equals negative 71. Here's my x that wants to be alone. 7's gonna hang on until the end, right? It's hooked on, which means it's gonna hang on until the end, which means who needs to go away first? Plus
13
13. How does plus 13 go away? Minus.
minus 13.
Minus.
Equals 7x plus 84. I mean, 7x equal 84.
What kind of 84?
Negative 80.
Because a negative and a negative equals a
84.
positive.
Now we're adding and subtracting, which means those
Negative.
9 different sign rules don't come into play. Think about it
Okay.
temperature wise. If you're at negative 71 temperature and you go down 30
Oh, negative.
more, you lose 13 more. You're subtracting 13 more. Where are you going to end up at? You're going to be even lower, right?
Mm-hmm.
Negative 71 and you go down 13 more. Now you're at negative 84.
Okay.
Or punch that guy in. What would I tell my calculator? Negative 71 minus 13. Negative 71 minus 13. Negative 84. Okay.
So now
All right. 7 hung on till the end, but now it's got to go. How did the hooked on numbers go?
divide.
Divide. X equals, and the good thing about it is if you did that last part in your calculator, negative 84 is the last answer that you had. If you just want to divide that by 7, you can just go ahead and type in now, just divide. That means that's going to divide my last answer by whatever I tell it to divide by. So I want to divide it by 7. Negative 84 divided by 7 gave me negative 12. Ooh, look at number 9. Ooh. Hang on. Before we do number 9, because it brings in all kinds of stuff, right? It's got all these crazy fractions and everything. But before we do that, I want to do something else real quick. I want to show you what you would do in this situation. Okay. Now, remember, keep your equal sign where it is. If looking at this side of my equal sign, remember X wants to be alone. What do you notice about that we haven't seen before though? Don't I have
Like,
more than one, I have multiple X's on the same side of the equal sign. If that occurs, you want to put those together. There is not a reason in the world to write on the same side of your equal sign 2x plus 3x. Because what really is that? How many X's do you actually have? You have
5.
right? There's no reason, since you're on the same side of this equal, to write those separately. This means the same exact thing as 2x and 3x, 5x.
I'll take that coffee.
Drop down your 10. And then you would do what? Divide by 5.
X equal 2.
Okay? So just keeping that in mind, because now when we go to number 9, we run into this, same X's on the same side, along with all kinds of other stuff.
so it's kind of like the problem you just showed us, just adding the like term.
Just add, I'm gonna put the like terms together, and it's just got fractions, but I'm just gonna make my calculator do it. 5/7x plus 2/14 x. equals 36/14.
36/14.
Okay, so just like that practice one that I just put on the board, those are X's that they're on the same side. So I'm gonna go ahead and put them together, right? Here's my equal sign. So I wanna figure out how much X I really have. So I'm just gonna add those together. So what do I need to tell my calculator to do for me? 5/7 plus 2/14. I know they're gonna be X's. I don't need to even worry about that. It's gonna be some amount. When I put those X's together, I'm still gonna have some X's. I just gotta figure out how much I have. So I'm gonna tell my calculator 5/7, which means 5 divided by 7. You can, let me tell you this, you can't ever go wrong with putting your fractions in parentheses. So open parentheses, 5 divided by 7, close, plus, what's your second fraction? Open parentheses, 2 divided by 14, close. Ooh. Is that what y'all got? 0.85714 something?
Mhm.
Don't want anything to do with that, right? What am I gonna do?
Math, enter.
Enter to see how much X I have. So
Hit math, enter.
math, enter. So I actually have, when I put these two together, I've got 6/7 X.
6/7.
Just drop this down, 36/14. Now, what's happening? Is this hooked on to the X? It's a fraction, but I don't care. How do you get rid of hooked on numbers?
Divide.
You divide.
Dividing by whatever it is. So there's my X all alone.
X equals 3.
So now I am going to put my fractions in parentheses because I'm doing a fraction divided by another fraction. So I'm going to have fraction bars everywhere. So let's put our top fraction in a parenthesis. So open parenthesis, 36 divided by 14 divided by, open parentheses, my bottom fraction, which is 6/7. Oh, didn't even give me a decimal, did it? Did I do it right?
I did it mine backwards.
X equals 3.
Yeah. Yeah, do it exactly like this says right here. Yeah.
Yes,
So X equals 3.
3.
So you did open parentheses, 36 divided by 14, close parentheses.
I got a 3.
What's wrong, y'all?
Yep.
Seven. It's still coming up with this one.
Okay.
You trying to get sick, little mama? All right.
Okay. All right, talking about interval notation. Oh, you're doing over your divisions in between those two.
Oh,
See,
okay.
you have, so since you didn't put a division, you have two parentheses above it, so it's actually multiplying them together.
Okay.
Because it didn't have that, oh, yeah, that's all that
All
happened.
right.
Okay, thank you.
Okay. So this is the next three problems. What we're gonna do is turn this into what's called interval notation. Interval notation is like open parentheses and brackets, things like this. The first thing I'm gonna do is put this statement on a number line. And this right here, you can essentially just ignore this part. This is the part that's doing the work. This just says X is such that X is less than or equal to 2. So just kind of ignore that and go with this. This is the number that I'm going to put on my number line, whatever it is. Now, I'm either going to use a bracket or a parentheses on that 2. And the way that you tell which one you're going to use is whether or not you have this equal to bar. See how this one has it, but these don't? That's the difference between using a bracket or a parentheses. If it's got the equal to bar, it's going to use a bracket. That means you want to include the 2. That means X is all the numbers that are less than or equal to 2.
Can you say that again?
Yeah,
So it's 1 and 0.
and numbers go below 0. They just go into the negatives, right?
Okay, okay.
So let's think. I'm going to draw an arrow on this. I'm glad you said that because now I want to know where all the numbers less than 2 are, which would be what? All the numbers forever that way.
E.
All the
Okay.
way to, we're going to call it what's called negative infinity. That means you're just going on and on and on. That's what infinity means, right? The numbers that are less than 2 go this way through the 0 and all the way to the end of the number line, which actually never ends. It just keeps going. That's why it goes to negative infinity. So this side of the number line travels to negative infinity. This side travels to positive infinity. That's what those sideways 8s are. They're infinities. So now I'm going to draw my arrow this way. Now, did we say that this 2 needs a bracket or a parenthesis? Do you remember?
A bracket.
Bracket, because it's got this equal to bar. So I'm going to draw a bracket this way because that's the way the numbers are going, right? That means starting here and going forever that way. Once
Okay.
you put it on the number line, then translating it from the number line to what's called this interval notation is essentially just pulling it off the number line. Okay, so what I want to do is have this bracket, this ending bracket here with the 2. Where did the numbers start? This negative infinity is where they're going to this way, right?
Correct.
Infinity, whether it's negative or positive, you don't ever have to think about it. It always is a parenthesis, 100% of the time. The only time you have a bracket would be around a number that had an equal to bar with it. So this X is less than or equal to 2, and this says from negative infinity to 2. Those mean the same thing. X is less than 2 means this all the numbers below 2 to negative infinity. So here's your answer. That, and when you're typing in this answer down there in the bottom, you will have those sideways 8s to choose to be able to plug in that answer. Okay? I can't remember which one's next. Is it this one?
The 5.
The 5s? Okay, so this one's next. So this time, this one only had one number on the number line because there was only one number showing right here. This has two numbers showing. So I want to put any numbers showing. I need to represent them on the number line. Okay? I don't care about any of the other numbers, just those. So on the number line, sometimes I'll put a 0 just because I like to see the middle of the number line. It's not necessary. Where would -5 be? It'd be somewhere over here, right? Below 0. Where would +5 be? Somewhere over here because it's bigger than 0. Because if the x is in between two numbers, that's exactly what it means it wants to represent. X wants to, I just want to show what's in between those two numbers. So now x is between -5 and 5. So everything in here. Those are all the numbers between -5 and 5, right? So now I just need to decide whether that 5 and -5 gets parentheses or brackets. They both get parentheses, right? Because neither
Right.
one of those numbers has the equal.
It's equal to sign.
Right. So parentheses, parentheses. That represents all the numbers between -5 and 5. So now that I have the number line showing, just drag that off the number line to show the interval notation. So all interval notations have an opening symbol and a closing symbol. The opening symbol is right here, which would be open, -5, comma, 5, close. That means all the numbers between -5 and 5.
Let's see.
Ooh.
I don't know, right? This one, be careful on this one. When you're that, this is why I like drawing the number line first. It's not you don't have to. You can go straight from this to interval notation, but on problems like this, again, anytime I have two numbers, I like to put the 0. Where would -2 be? To the left of it. Where would -6 be? Even more left, right? Because my negatives go, where after -2 would be -3, -4, -5, -6. Here's where -6 would be.
What you eat for dinner last night?
Mm.
For dinner last night.
Okay, it's parentheses.
And they both, and you're exactly right. They both get parentheses, right?
Yes.
They don't work with.
Neither one of them have the equal to bar. So open parentheses, -6, -2, close parentheses.
Trying to do this by yourself, doing it by yourself is so difficult compared to when you explain it in the whole
I
number
know.
line.
And you know, the math lab help features are sometimes helpful and sometimes not. Because a lot of times they will go very roundabout. Sometimes I don't understand their way of thinking. They go some roundabout ways to get to where they're going.
Yeah, the way it was looked on there was kind of confusing too.
Okay, so these are multiple choice. 13 and 14. So on 13, this is the drawing. I didn't draw all the numbers. I just drew the numbers that are represented, that -3 and that 4. It gives us the number line. You literally just yank that off the number line. That's why I did the number lines on those other ones, because once you see the number line, writing it in interval notation is literally just pulling this right here off the number line. So open parentheses, -3, comma, 4, close parentheses. You literally just yank it off the number line. Same thing on this next one. Yank it off the number line. The opening symbol is going to be a bracket, just like it is on this number line. -4, comma, there's not a closing number. What does this mean? What does this arrow mean? That is going to
Infinity.
That arrow means it doesn't stop at a number. It just keeps on going. So I have it
So infinity parentheses.
inside. And what goes around an infinity always? A bracket or a parenthesis? Always.
Parentheses.
Parentheses.
That's right. Every time. Oh, how many we got?
We on parentheses and brackets.
All right, number 15 says a plus 6 is less than or equal to -13. It wants us to solve it and then put it on a number line. Solve it just like you did your equations. Get the a by itself, which means plus 6 needs to go away. So I will subtract 6. So A, just drop this symbol down, whatever it is, less than or equal to. Now remember, we're not multiplying or dividing, so we're not using those same sign rules.
-19.
-13 minus 6, or if you're at -13 degrees and you go down 6 more, now where are you at? You're at
-19.
-19. So then it gives you a multiple choice situation. It says the solution is, it doesn't want interval notation. It has these choices. So it has multiple choice. Choose A, B, C, or D.
I wish you gone on.
Just match your symbol. This symbol. Which means you
My
choose this one,
thing will go out. Plug it back in there.
right? You would choose that one and then just put your answer in. So -19. And then it's got a multiple choice graph to choose from. So let's see, or a number line, not necessarily a graph. So let's see, there's my 0. So -19 is somewhere right here. What does this say? A is less than this number. Where are the numbers?
That's a bracket.
Stand to the left. So my arrow would be this way. And good. What does this mean? That equal to bar means that has
A bracket.
That's right. So whichever multiple choice had a bracket on -19 with the arrow going to the left.
Okay.
All right, we got time to do, so I'll have time to get through 2 more. Number 16, 9x is greater than or equal to 36. Okay, so solving this one, the 9 is hooked on. So I'm going to divide it by 9. So what does this say? X is greater than or equal to 4.
4.
So that's the one, you would just pick whichever, it's multiple choice again. You would pick the one that says X is greater than or equal to 4. Number line, there's my 0. So my 4 would be right here. This says X is greater than, where are the numbers greater than 4?
To the right.
Right, all the way.
Going that way.
And does 4 have a bracket or parenthesis?
Bracket.
A
Right,
bracket.
that's right. All right, I got time to do one more. I'm gonna do,
To the fraction.
I'll do the fraction one. Number 18. This does bring up a new thing that we haven't seen yet. Negative 7 over 2x is greater than or equal to negative 3 over 4. All right, did I get all my signs going all right? Yeah. Okay, solving for x. Is that what is there's a number hooked on? The only thing I need to get rid of is that negative 7 over 2, right? And it's hooked on. How do you get rid of hooked on numbers? No, add. It's hooked on. Divide by exactly what it is, right? Because if I put it over itself, that's what's going to cancel it. So I'll divide this side by negative 7 over 2. Now, x is going to come down. That's all that's left over here. Here's something new and different about inequalities, which means not an equal sign, but a less than or greater than sign. So anytime you multiply or divide both sides by a negative number, this turns around. So multiply or divide by a negative number, this symbol flips around. So it's going to go from greater than or equal to less than or equal to. And then do that math. Since it's division of fractions, I'm going to put each fraction in its own parenthesis. So I'm going to have open parentheses, negative 3 divided by 4, right? Because that's what's in the top. Divided by. Open parentheses again, negative 7 over 2. Negative 7 divided by 2, close. So again, I have the top fraction in a parenthesis divided by the bottom fraction in a parenthesis. Oh, did you push the minus button instead of the negative? Try that. So I got a crazy decimal, so I'm just going to math enter to get 3/14. And it is multiple choice. It doesn't give me a number line on this one, I hope, does it? No, you're just writing the answer. It doesn't give you the number line, which is good. So you remember, make sure your sign turned around to less than or equal to. So make sure you choose the multiple choice that has the less than or equal to symbol. Okay? Okay, so since we don't have support.
What was the answer?
3/14. X is less than or equal to 3/14, right?
Mine is split. They got 14 over 3.
Oh, yeah, I got that same thing. Okay. So how did you make it a fraction? Because I had that big number.
Math.
Math,
Enter.
okay.
Math, enter.
Enter. Gotcha. I remember that.
So in college algebra on Friday, we are going to be covering 2.4. So between now and then, I'm going to just pre-make a video and put it in your week 2 folder so that you'll have a video to go along with your support for 2.4. Okay?
Okay.
All right. See y'all Friday.
Have a good day.
Thank you, you too.